Okay, everybody, we're going to look at exploring again how sinusoidal functions can model real-world situations. Today we're going to look at ocean tides. So we're going to also learn how to use our calculator, again, to evaluate expressions and how we can use our calculator to solve equations. So this function here is going to give us the height of the tide at Morro Bay, where x is hours since midnight, and f of x is the height of the tide in feet above the seafloor. You can see here that I set up my graph to have x time in midnight, and my y values are going to be height in feet. You might want to pause the video and copy this down so that you can get ready to graph along with me. So I think we're at the point now where we can begin to do our graphing a little bit more quickly. You can see here, because of the 10, that the midline of this function is going to be at 10. So I'm just going to draw that horizontal line here at 10. And then the amplitude is 2.5, so that means we're going to go 2.5 units above and 2.5 units below the midline. We also need to figure out the phase shift. The phase shift is going to be 1 unit because 1 minus 1 is 0. And we have to figure out our period, so that's where we need to maybe show a little bit of work. So the period, 2 pi divided by pi sixth. When I rewrite that as a multiplication problem, 2 pi times 6 divided by pi is going to be 12. So that means that the tides are on a 12-hour cycle. Remember, x is going to be time in hours since midnight. All right, so if we have a sine function and we are going to translate it 1 to the right and up 10 units, I'm going to start my graph over here, and this is going to be 1, 10. And then I know that the period is 12 units long, so I'll return to this point after 12 hours. So that's going to be 13, 10. Right in the middle of 1 and 13 is going to be the next time my cycle. It's going to go like this. It's going to get back down to here. So that's going to be 7, 10. And then we'll have our graph going 2.5 above and below. So 12.5. And then down to, let's see, 2.5 minus 10 is 7.5. And here's a graph of this function. We could go ahead and figure out the coordinates of these points. The point right in between 7 and 13 is going to be 10, and that's going to be 7.5. And then the point right in between 1 and 7, if I add 3 to this, is going to be 4. So that's going to be 4 and 12.5. All right, so let's go ahead and answer these questions. When is the first high tide after midnight? So the high tide is going to be the maximum point on our graph. How many hours after midnight is it? 4. So the first high tide after midnight is going to be at 4 a.m. When is the first low tide after midnight? The low tide corresponds to the minimum point on our graph, so that's going to be at 10 a.m. How much does the height of the water change from low tide to high tide? So the height of the water at low tide is 7.5 feet, and the height of the water at high tide is 12.5 feet, and that's a change of 5 feet. Here's the part where we're going to need to use our calculator. So it says here, use your calculator to determine how high the tide will be at 11:30 a.m. That's going to be when x is 11.5, because that's 11.5 hours after midnight. So on this one, we know x, and we want to find y, or f of x. So let's go ahead and zoom in a little bit and get the graphing calculator out. I've already entered the function into my graphing calculator. I wrote it exactly like it was on the paper. I also already set up my window. I actually went from 0 to 24. That would be the hours in a day. Remember, X is time since midnight in hours. And then I went ahead and went up to 20. I knew the midline was at 10 and my amplitude was 2.5, so 20 gave me plenty of room to graph this function. So now we're seeing the tide over a 24-hour window of time as opposed to just 12 hours on our graph. Second, calc. Let me move this up and show you that again. Second, trace, which is where the calc menu is. We want to find the value of f of x. And we want it to do that at 11.5. So 11.5. You have to press enter. I'm off the screen pressing enter right now. And so you can read from the graph here that that's 8.23. So let's round it to the nearest tenth. And we can write our answer like this. F of 11.5 is approximately 8.2 feet. And we can see if we go to where the graph, where 11 would be, it's going to be right around here somewhere. That seems to be reasonable because our lowest value was 7.5. So we should be somewhere between 10 and 7.5 at 11:30, which will be just after 10 on our graph. Okay, the next part down here says that we want to find when the tide will be exactly 12 feet. So now we know f of x, and we want to find x. So the way that we do this problem is we're actually going to make an equation. We want to figure out when f of x is exactly 12 feet. So what we do here is we're going to enter into y1 our sine function. I already have that done. And then in y2, I'm going to enter the other side of the equation. I'm going to enter 12. Let me show you. So right here, I'm going to enter in 12. And now what we're going to do when we press the graph is we're going to see the line y equals 12 intersecting our graph. And each of the places where the red graph intersects the blue graph is a time when the height of the tide is going to be exactly 12 feet. So now what we need to do is use the calc button again on our calculator to find those points of intersection. So second, calc, and we want to do number 5, which is the intersection point. I'll model one of them for you, and you can practice finding it on the other. So the keystrokes that you use on your calculator to find the intersection points is you arrow over until you're close to one of them. And then you're actually going to press the enter button 3 times. Here we go. 1, 2, 3. The third time you press the enter button, it makes a guess as to what you think the intersection point is. You'll know you've pressed enter enough times when the word intersection appears right here. So I can see that when y is exactly 12, the x value is 2.77. So the solutions to this equation are x is approximately 2.8 hours after midnight, so almost 3 a.m. And then we would have to actually go and find this intersection point, and this intersection point. You might want to pause the video for a moment and find those intersection points on your own. I'll also pause the video, find the intersection points, and we'll come back in just a minute to get those values. Okay, pause now. Okay, so you can see that I found the other 4 intersection points. They were at 5.3, 14.8, and 17.3 hours. Again, that process is to do second, calc, select intersect. Move the cursor to the intersection point you're trying to find and press enter 3 times. All right, I want you to notice something here. Do you see how these 2 times are exactly 12 hours apart? And that's because they are going to occur exactly 12 hours, the period, after one another. So you could probably solve this problem just by finding the first and the second intersection point and then using the period to add on the number of hours until the cycle repeats itself. All right, let's recap what we did on this short activity. We saw how a sinusoidal function could be used to model a real-world situation like tides. We constructed a very rough sketch of this and paid careful attention to making sure that we labeled our axes with the real-world quantities that were represented by this function. And then the big thing that we did that was kind of new is we actually went down and we used our calculator to do two things. We used our calculator to find the value of the function when we knew x, and that was from second calc value. And then we also used our calculator to actually solve an equation, which is what we have to do when we know the f of x, the output, and we want to find the input x. So I made the equation f of x equals 12, and I used the calculator to solve it. We did that by entering each side of the equation, one side in y1, one side in y2, and then we found the intersection points. Of the intersection points of these two equations, and we used second calc intersect on our calculator to do that. If you're still struggling with the keystrokes to either do second calc value or second calc intersect, you can probably pull up another YouTube video, not made by me, but by somebody else that would show you how to do that. Okay, so on the back side. Yesterday in class we talked about, or actually 2 days ago in class, we talked about if you know the maximum point and the minimum point, you can write the equation of a function. So here we have one that says the tides vary plus or minus 4 feet from a mark on the pier that is 5 feet above the low water. The first high tide is at 6 a.m. and the next high tide occurs 13 hours later. So we have our high water mark here. And that is 5 feet below the low water mark. So I'm going to put 5 here, and the x-axis will be our low water mark. And it said we're going to go 4 feet above and below this. So up to 9 and down to 1. Okay, 4 feet above or below. And it said the first high tide is at 6 a.m. So at 6 a.m., we're going to be at 9 feet. And then it says that the next high tide occurs 13 hours later. So if I add 13 to 6, that's 19. So 19 and 9. And then I need to find the number that's right in the middle of 6 and 19. So that's going to be 6.5 more. So that will be 12.5. And that's going to be my low water mark, which is at 1 foot. So here's your curve. So the period is equal to 13, which means the b value is going to be 2 pi 13ths. The period is 13, the b value is 2 pi 13ths. You can see that the amplitude is going to be 4. The midline is y equal 5. And if we start at our high point at 6, then we'll have a phase shift of 6. You might want to pause the video and discuss with the neighbor how you found those numbers, or how you can make sense of those numbers. All right, whoops, the answer was supposed to go here. Let's write a formula for the function. F of x is equal to 4 cosine 2 pi 13ths times x minus 6 plus 5. This is what we were working on yesterday. All right, folks, that's all we have time for. Okay, so what I would like you to do now that you've had a chance to watch this video is work with a partner or someone sitting near you to answer these 3 questions based on the work that we just did, and then you're free to start working on the homework assignment out of your book. There are some directions to do some homework down here on the bottom of your page. If you'd like to do this assignment, we're going to count that one as extra credit. And you can put this work on page 61 on the notebook part of your notebook. All right, you guys, we'll see you next week when I get back, and I hope that you found this video helpful. Bye.